artificial intelligence. So that's it in a nutshell, really. A lot of people confuse machine learning and sorting algorithms as artificial intelligence. A lot of people confuse AI as some sort of super intelligent sort of software code, intelligent being. And it may well end up that way. But at the moment, artificial intelligence is a collection of algorithms that try to reach an objective. And the objective, of course, can be anything. Now, the challenge that everyone talks about is that what if humankind is in the way of the objective? Now, you may have come across a guy called Nick Bostrom, who is the head of quantum computing at Oxford. He wrote some great books about this. And the conclusion was that when you deploy artificial intelligence as code, as a series of algorithms, they will follow and try and meet an objective. So what happens if humankind, you're not allowed to call it mankind anymore, you have to say humankind. What happens if humankind is in the way? Interesting. So there's lots of different types of AI, and previous speakers and other people in other conferences will tell you all of this sort of stuff. So we have narrow AI, which is pretty much what most AI is out there today. Self-driving cars, trying to play chess, trying to play Go, board games. Narrow AI. Then we move on to more of a general AI, where you could think of, IBM Watson in a sense, where it has a broader spectrum, broader computing, broader reference point that enables it to come to much broader conclusions and work out much more complex situations. And then I postulate that also the advent of quantum computing, therefore quantum AI, is the accelerator towards superintelligence. And that's where the AI thinks for itself. It decides what the objective is, which is, in many views, a dystopian future. It could go either way. Mankind could do well, or in Elon Musk and Bill Gates' view, it could be an existential threat to our civilization. So it's a complex array of, when people talk to me about the ethics of AI, I think it's a bit of a non-question in a sense, because the AI doesn't hate us. The AI is a non-emotional, uncaring set of calculus that is trying to reach an objective. But will it work on strategies if they detect that we are in the way? And I'll leave you to think about that for a second. So, you may have heard of the board game Go. 19 square board, and the objective is to encircle your opponent. It's a very complex game. There are billions of moves, literally. And of course, the guys at DeepMind, the alpha team, they taught this machine set of algorithms to play the game. And they started winning, and they started beating the world champion, and it was all good. Then they used something called the Monte Carlo model, and what that is, it's a model of identifying the most efficient algorithms and learning experiences, and they created a new version of the alpha AI, which had never played a game, but it was just watching what the old one did. And the old game took 6 to 8 months to learn, and it beat the world champion 4 games to 1. The new one took 2 weeks to learn, and beat the old machine 100 to 0. Now, the problem I have with this is the rate of learning. If you go into the AI community, and there is a lot of people globally in the academic community concerned about this, It is not AI itself. It's the ability for the AI and the rate of learning which is increasing exponentially. But there is another problem here. Progeny. The AI is starting to create AI. Now, the AI that Google admitted to, after being probed a little bit, they admitted that one of their AI programs had created another AI which they didn't understand. So therefore the problem is, has that AI deployed code? Has it deployed code, for example, in a 747 that turns the overheating sensor off on an aircraft? But they don't know. Another example of singularity in a sense. We've passed the point where we can put it back in the box. Now, people will tell you, we are decades away. Don't worry about it. Nothing to worry about. You're being lied to. Quantum. Quantum is probably the most stealthy technology. I call it the fourth wealth creation revolution. The first was steam. Okay, that drove the Industrial Revolution. The second was electricity, and that drove the manufacturing revolution. The third was transistors, which drove the current revolution of technology-led wealth creation. The fourth has just arrived at the station, and it's quantum, and you can include quantum AI into that. Why is it the fourth wealth creation revolution? Because quantum allows you to solve mankind's deepest and biggest challenges. It can also unhash encryption rather quickly. And it's interesting, isn't it? So there may be some of you that are used to security, cyber security and what have you. Did you know that our only defense against hacking is computers' inability to factorize large numbers? So if I said, what's the factor of 15? You say 3 and 5. We can work that out quickly. RSA encryption generates a 600-character string. Conventional computers would take 10 million years to work that out, so you can't unhash it. Quantum can do it in 100 seconds. Now the question people say, Nick, quantum's miles away. Well, actually it's not. It's at the station. Google arrived, Google announced their AI supremacy had been reached last week, I think it was, or the week before, 73 qubits. And a qubit is it's really a coefficient of a bit. A bit is a 1 and a 0, a qubit can be multiple states at the same time. Now what does that mean? It means massively powerful brute force computing. That's what it means. The magic number is 108 qubits. Google say there were 73. IBM say there were 50, 60. I know 2-3 projects are already at 200. The Chinese projects, the Chinese Ministry of Science and Technology have been on quantum for a decade or more. Quantum is not new. Quantum physics has been around since the turn of the century. We are at a significant turning point in our understanding of the world around us. We think the world around us works a certain way, but we don't know for sure because physics and chemistry and all the things we learn at school are probabilistic rules. They are fixed. The apple falls from the tree. We know the velocity of that apple. We know the weight of that apple. But was it windy that day? Was the tree on a hill? Had a wasp buried into that apple? That's the non-probabilistic world of quantum. It considers everything. So therefore we can understand how the world around us really works and really behaves. Now I don't know how you feel, but quantum computing, I think they're quite amazing looking things. This is IBM Q by the way, with all the casing removed. Now, the reason that Moore's law is not working is because we've reached the limit on the micro scale, or the micron scale, of how many transistors we can pack into a piece of silicon. We're now at the limit of particle physics because it generates enormous heat, you get interference, and performance drops off. So Moore's law is finished. Conventional computing is finished. We are already at the particle level. Now, the magic happens at deep space temperatures, or as they say on the Kelvin scale, absolute zero, minus 437 degrees Fahrenheit. That is the magic that quantum operates at. Why? It's because at that temperature, photons and particles slow down, and you can influence them. When you can influence them, you get massively parallel processing power. The issue is coherence. These little particles, there's an old, if you look up Schrodinger's cat, okay, you put a cat in a box, there's a vial of poison in there, and you bombard the box with various things. Is the cat dead or alive? In quantum terms, it's both. It's both dead and alive. But you can't measure or look inside the box because you'll disturb the experiment, which is quantum. But it's here. And they're rather amazing bits of kit, actually. They weigh probably, in its entirety, about 25 tons. Most of it is shielding and cooling, what have you. So this is where we are. So how do we wake people up? We have the XYZ generation that are completely disenfranchised. I know, I've got 4 in my family. My children are between 21 and 32. They don't like banks, nor do I. They don't trust government. The brands don't know how to reach them. And they feel completely disenfranchised. So how do we wake that generation up? Because they are now 35 to 40% of the working population. They're important. So who enjoyed the film The Big Short? Okay, great story, wasn't it? Michael Lewis, good form. But here's the problem with it. Very informative, explained a lot of things about what a credit default swap was and this and the other. But the problem was, it's after the event, which is no good. We need to wake up the next generation, this generation, before the event. So, decided to make a TV miniseries about it. As technically accurate as possible. And now I'm going to show you the teaser for the first episode. So brace yourself.
Guys, mind you all there?
Welcome, Josh. You've already started explaining what we found, Mr. Wright.
Explaining what we found?
The drug is dangerous. Failures are not insignificant, Mr. Writer.
You hear those sirens? They're here for you.
We are dead, son! So dead!
These could... What did you do?
But we're boring. No wonder we like them.
So I'll give you a little insight into this story. So the story follows a blockchain company that makes a discovery. And a discovery that advances computer science 30 years in a single motion, really. And of course, they discover a way of unhashing data. Now the series, which I've also written, and will go into production next year, is written in a way that it's set against the existential risk of AI. The race for AI supremacy between China and America, primarily. And Mr. Robot is in season 4. If you look at Mr. Robot, why it's successful, it's because it's technically accurate. The the hacking tools used are real, the problems they do are real. I sort of lost my way at season 2, I have to say, when it became a little bit weird. But this series is going to be as technically accurate as we can make it. And the short film we've made, so think about the parallels. We did an ICO, so there was some clown on stage this morning that said all sorts of weird things. But this is an ICO that actually we did in June 2017. We raised enough money to make an MVP. So think of this short film as an MVP. The parallels of building a blockchain, we were actually the first project not to build a blockchain. But the parallels are very similar. You need a story, which we have. You turn that story into a set of requirements for your software development, which is a script, and then you make product. So the parallels are very similar. Making content, parallels to making, you know, a viable product. So here we are. The project that clown this morning said is never going to deliver and is a bit dodgy is here. And it's not only here, it's got a whole bunch of stories and themes in it that resonate with today's audience. So we have characters in it that are vegans, we have hunt saboteurs, we have people in it that don't like animal cruelty, we have climate activists. We have all the storylines and the themes and the plots in it, as well as the conspiracy theories and the quantum stuff and the AI stuff. And as I said earlier, and this is my last statement really, AI is an existential risk to humankind, but it will not manifest as a Terminator machine hunting people. Thanks for your attention.